go ahead and open up the bike rentals data set, link provided in the video below. If you have a link, go ahead and make your own copy. File, save a copy in Drive. And what I want to do here is be clear about whether we need a regressor or a classifier to do machine learning with this, and look at how that actually changes the machine learning model that we use. So this is the preliminary, and I do want to just highlight here, okay, we have all this data, and we are going to try to predict why is DF casual, the number of casual users. Now that's different than the number of registered users, and combined they give you the count. Sometimes I, like to predict the count. So this is a little different sometimes than what I do. And the other thing is it's starting with season as the first predictive column, not the instant. The instant is just like the index. It's just like goes in order. And this can actually be useful, but it can also be something that you don't want to take into account. Why might it be useful? Because early numbers means like maybe earlier in the company's lifetime, which could affect the outcome of like later. This is only over 2 years. Okay, but I can tell you it does play like a surprising role in this data set, depending on what you end up with. But it's clear that, a nice machine learning model, you would just be looking at the weather, the holiday data. Okay, and you have that, and you want to use that to determine how many casual riders, meaning non-registered, will come to rent bikes. Okay, so with that set up, we can go ahead and run the code. And preparing for machine learning, what we're going to do is we're going to split the data into a training and a test set. So let's go ahead and do that. So from sklearn.model_selection, import train test split, and then we are going to split the data, and we do that using xtrain, xtest, ytrain, and ytest. Okay, we're splitting x and y into 2 new x and y's, which is why you have 4. And that goes to train test splitting x and y. Note the conventions are kept with capital X's and lowercase y's. So go ahead and run that. Okay, now we want to build a machine learning model. And since we are trying to predict the count column, the casual column, the C and T, well, you can clearly see it takes on a range of values. This is a regressor. And so if we're going to use a decision tree, let's go ahead and try that. We want a decision tree regressor. So from sklearn.tree, okay, there are 2 types of decision trees. There's a import. Right, so we're going into the tree library in sklearn, we're importing look, you see the 2 options there, decision tree classifier and decision tree regressor. And so this is what I mean about the importance of knowing whether your data set is regression or classification, because everybody has different data sets for their project, and one person may need a classifier and another person may need a regressor. Well, since we are dealing with regression here, it is a regressor, okay? So let's see now how will we do on this data set as a starting point. So let's go ahead and get started. So what we're going to do is we're going to set the model. Model equals, initialize it, Decision Tree Regressor. Now we're going to fit it on what? Well, it's on our training data, right? This is where we're building out the model. And then we're going to see how will we do on the test data. Okay, and so the idea here is after you build the model, then you put in this new X and Y, right? Okay, this new X and Y, and you score it to see how well it does. Okay, so let's get that code up, go ahead and run it and see what our starting place is. It's pretty decent, like 74%. What does that mean? I said 74%. I probably shouldn't. That's the R2 score, okay? We'll look at some different scoring metrics later, but for now, do note that what that means is 74% of the data is captured by the model, okay? So pretty solid, and we don't know if that's overfitting or underfitting, but recall with a decision tree, you can modify, say, the max depth. And so, we could go for like potentially something smaller and see what we get, 77, a little better. And then you can keep kind of just tweaking this a little bit, about the same. Now, if you're getting about the same when you go down, you go down too low. Let's recall what max depth of 2 means. That means you're only asking it 2 questions. So it might be something like this. Is the temperature over, let's just put these into real terms, 60 degrees, and is it a weekend? If so, we're expecting a high number of rentals. And so, hey, that could explain something like 67% of the data, but we do better if we ask a minimum of 3 questions, which is what we're seeing here. And sometimes you can also see gains if you go higher. If we ask a minimum of 7 questions, it's starting to overfit what's there and not generalizing well enough on the test data. So that's really kind of a nice starting place for us using our decision tree regressor. And so a natural question that arises is, okay, once we know that we're in the world of regression, what options do we have?